So in this video we will understand the principle of restriction enzyme digestion and ligation. And before we move, I want to tell you about the two types of restriction enzyme cutting patterns. So when the restriction enzyme cut, it can cut in two ways. One, after cutting it can create a blunt end, or it can create a sticky end. I will explain you what is the blunt end and the sticky end. So take this as an example of plasmid. If you cut with a restriction enzyme at this place, it will make this linear, and the blunt end means it will be very, blunt. They will not sharp, they will not sticky, no extension outside. So you cannot fit a concept of lock and key here or something. So it's very general, and they are not very good for ligation of they are not very good for ligating gene of interest to the vector DNA. On the other hand, the sticky end is also I will explain the sticky end. And for example, the same plasmid, and if an enzyme which creates a sticky end somewhere, so there is enzyme cutting site which is here, and it will make the sticky end. How the sticky end will look at the end after cutting, you can see that there is some extension. So if it's double stranded DNA, so the one strand it will cut here, and the second strand will cut like this. So it's sticky end means there is some kind of extension after cutting, which you can say the flanking region at the end. So this is the sticky end, and you can feel that if you have some other molecule like this, which you so I will explain this concept also to you. So assume that this is gene of interest which you want to ligate with this, but you cannot ligate it. Nothing can stop here. Just when you mix these two DNA, it just flank, nothing will stay. Okay, and the same can apply to now. You can take this example. So if you want now to flank this, you can see that it's not very flexible. It will rigid, it will stick here, and then it will try to find out where is the place to attach, and then it is easier to attach any DNA molecule in a sticky end pattern. So that's why people prefer in cloning those enzymes which create the sticky end in the plasmid. Okay, how it will work in a real time with any restriction enzyme, I will explain it here. So for us, we are using the two enzymes, which is NHE1 and XHO1, and we will take first the example of NHE1 here. So as these arrows are telling when the NHE1 will work on this sequence, it will cut at this place. Okay, so assume that there is a double stranded DNA. If you cut something here, okay, and you will cut something here, so it will remove, let's just hide this part, so it will remove this part. Okay, it will remove this part, and it will remove this part. So after cutting, just make it more prettier. Okay, so after cutting, it will remove this part and this part. So at the end you will have two portions. One is this, and one is this. So assume that if you have this is your gene, and this is your gene, and this is the NHE1 site here. So after cutting, you will get some flanking region like this here. Okay, so that's what you will get at the end. It will make a sticky end here. Okay, in this part, as we remember that on this side we have some fodder region. So for the reason I'll explain this here. For example, here you can see the sequence. This we just GCG80 we added as a fodder sequence. So once we'll cut, it will cut one portion like this complete, and it will cut another portion like this. So this will be just removed. So one side which is free will remove, and then you will get these kind of sticky ends. So we will use this one. This is discarded. So only this one is needed here. The similar will applies to XHO1. Okay, and so this is, in this example I showed you how the cut how it will look after the cutting, and here I will explain you how it will look in a plasmid also. Okay, so if you have the plasmid, so you remember that this is the plasmid here, and then you have the NDE1 and XHO1 cutting site here. So you will cut the plasmid NDE1 and XHO1. You will create two fragments. One will be the whole plasmid, this one, and one in this fragment which you'll remove. So it will be like this. So if you will cut this, you will create this whole plasmid separate, and then this will be removed. This will be discarded because we don't need this part, right? The origin of replication, Plasmid register, and etc. all the features. So if you remember, then after cutting pattern, it will look something like this. This is for NDE1, and this is for XHO1, which will be here. Okay, and this part will be just simply removed. And how our gene of interest will insert it, as I explained you, after the cutting the gene of interest, you will have the sticky end on both sides. This is NDE1 sticky end, this is XHO1 sticky end, and that's how the sticky end will join. So this will be NDE1 of the plasmid. Let's say kind of amplified, and this is the XHO1 of this side, and there's a gene of interest with the XHO1 here and NDE1 here, and that's how they find and forming a chimeric DNA at the end. I will explain this same concept to you in more proper way here. So assume this is your PET21. You will cut this enzyme with NDE1 and XHO1 in principle, as I told you. So you will create two fragments. One will be the larger fragment, which is on this side, this big one, and then you will create a smaller fragment, right? And the same, you will also digest the gene of interest with NHE1 XHO1, and after cutting, the fodder part will remove, and you will again have the sticky end with the flanking region of NHE1 and XHO1, and then you will mix this guy with this guy, and how it will form. So it's explained. I have explained you here. So this is your PET21, and this is your gene of interest, which will bind. And in real time, it will look something like this. And so here your gene of interest will go. That's how it will attach and forming a chimeric DNA. So that's how restriction digestion process occurs, and that's how these gene of interest and the linear vector DNA come close together, and because of these sticky ends, because of these flanking region, they got attached and then further ligated by the DNA ligation enzyme. So technicality will be explained in the next technical tutorial. Thank you.